day and a half on a range of topics around transmission, the grid, the importance of it, and we had this last panel that Alex moderated, which is very good, on this issue of transportation electrification. But I think when it comes to it, this is still a very technology-driven industry, and with all the transformation and all the changes going on regarding technology, I think now it's time for us to get a little bit of some diverse perspectives on the technology innovations that we see driving this industry going forward, both in terms of planning, operation, and maintenance. And we've got together here a very esteemed panel, and so I'm going to turn it over to Ted Craver, who will moderate the panel. Ted.
Thank you, Lawrence. I appreciate it. And on behalf of our panel, I'd like to welcome all of you and, of course, the panel members to session 6 entitled Technology Innovations for Grid Planning, Operations, and Maintenance. As Lawrence said, I'll act as the moderator of the panel. So let me start just by doing a brief introduction of myself and of our panel topic. I'm Ted Craver. I'm a member of EEI's Global Executive Leadership Network, and I'm the retired chairman and CEO of Edison International, Southern California Edison. I was the chairman of EEI in the 2014-15 term, and one of our panelists is from EPRI. I was the chairman of EPRI 2010 through 2012. The focus of this conference has, of course, been on transportation systems, and as such, our previous panels have discussed and explored transmission with increasing distributed energy resources, network expansion and cross-border interconnections, siting challenges, new business models, and opportunities in the electrification of transportation. But I think it's really fair to say that the technological innovations that we'll try to explore in this panel offer the promise to help meet the challenges raised in these earlier sessions, whether it be integrating distributed energy resources or improving siting mechanisms, interconnecting or network expansion, and certainly in furthering electric transportation. So we'll explore the technological innovations and how they offer better performance, lower costs, and greater capabilities for the electric system and, of course, for our customers. You have the bios in your pamphlet for my panel members, but let me just briefly introduce them here. Immediately to my left, Kevin Cosgriff. Kevin is the president and CEO of the National Electrical Manufacturers Association, or NEMA as it's more often called. He also is a 30-year plus veteran of the U.S. Navy, retiring as Vice Admiral. Manlio Coviello. Dr. Coviello is president of the board of Terna Plus, the part of the Italian energy transmission company Terna, devoted to expanding business abroad. In fact, he was just sharing some very interesting photos with us here, standing on the world's largest lithium deposit in Bolivia. And maybe he'll take a side trip in his remarks to tell us about how he spent 2 days there. And then Tom Wilson. Dr. Wilson is Principal Technical Executive in the Energy and Environment Group of EPRI, the Electric Power Research Institute here in the U.S. And Dr. Wilson's research focuses on system planning and integrating energy and natural resource systems, which we're going to explore a little bit in this panel as well. So kind of the nexus of electricity and natural gas, for instance. At this point, I'm going to ask each of our panelists to make their opening remarks and along the way introduce themselves and their organizations. After the panelists make their remarks, we'll enter into a dialogue on the subject, and we look forward to your questions. By now you're probably experts on logging into the system and submitting your questions, but also feel free to raise your hand and shout out your questions as well. So with that, Kevin, would you please start us off?
Thank you, Ted, and for those remarks. And I'd like to give a shout out to Tom Kuhn, who's my counterpart at Edison Electric Institute, for wrangling me into this opportunity. And I'll apologize ahead of time for my voice. I'm getting over a travel-related cold. I won't mention the country, but it rhymes with Britain. And when I left, anyway, there was a government, and the Queen was still the Queen. I don't know what it's like today, but it was interesting times meeting with my British counterparts about, well, what's on your mind? So, God bless them. Good luck to them. I'm, as Ted said, I was in the Navy for over 30 years. I was not a nuclear power trained officer, but if I've ever felt that I missed out on something, I feel that way today because I'm in a room full of people that really know this stuff, and I don't pretend to. So I'm going to defer to the experts if we get into the real technical aspects of the subject matter. Manlio, while he was talking about lithium, was doing some calculations about how much lithium the world's going to need to supply the batteries for the electric vehicle cars that are going to change our future. And I'll let him explain the math, but it looked to me like, at least in the initial stages, it's going to be using the element unobtainium to try to make that work. All that aside, NEMA is an interesting organization. We have 6 electrical divisions, more or less functionally organized around industrial systems, building infrastructure, lighting systems, utility systems, which would really be the focus of this conference, and a relatively new transportation systems division, because like our previous panel, we recognize that to make the contribution that we need to make to wean ourselves from fossil-intensive electric power, we need to tackle the transportation, or power in general. We need to tackle the transportation sector. And the statistics were given earlier. It's no small feat to accomplish that, but we're fairly confident that electrification of transportation is headed in a good direction at this point. We believe that connectivity will be an important part of that, and that's connectivity within the transportation space. There's a separate level of connectivity within the electrical space that will accompany it. But by and large, we're comfortable that over the next 2 decades, that's where we're going to go, and eventually autonomy will be amongst us. So it's going to be exciting times for folks that, like my new granddaughter, who probably will never own a car and won't know what an internal combustion engine is, we hope. So we'll see what her life is like. Electricity, as I like to tell audiences, is a blessing to modern life. It's the people who went before us have built the most complicated machine that mankind has ever seen, both in breadth and in scope. You could probably argue in contribution. How good is it? Well, in most parts of the world, electricity is absolutely taken for granted. It's not even thought about most of the time. So I asked a waitress the other night, sort of on a side bet with my wife, about, it's the end of the shift. She's going to get home at about 10 p.m. at night. So I asked her, what's the very first thing you do when you get home from work? And she said, I feed my cat. I said, no, the first thing. She said, that is the first thing. And I said, okay, I made the point that she just assumes when she hits the switch, the lights will go on. And I asked another friend, a Navy veteran like myself who had commanded a ship, what does she value most about electricity? And she said resilience. She said, I want it to be able to recover because I know it's a machine and I know it's not perfect, but I want it to be able to come back on quickly. So even in that answer, though, she assumes a high level of reliability, which is a testament to those that went before us, but it's also a challenge to the people in this room. The cat's name was Toad, by the way, in case you were wondering what, for completeness. So if in the real world reliability is an assumption, and it's just a given in the lives of the consumers, what happens in the few short years when more and more grid visible and interacting devices become connected in ways that we've heard about over the course of this conference? And talk about electrical engineering at the postgraduate level. This is going to be hard. Most of this is going to be in distribution and below sector, but certainly it's going to ripple upstream into transmission. It seems to me, though, what's really happening is on top of this very complicated system, we're now going to be adding a layer of complexity that we've never quite seen before. And complexity is a beast of a different color, and it's going to take all the good minds, similar to the people here, to get this right. One example of what I'm talking about is captured in the forthcoming work by the U.S. National Institute of Standards and Technology called Smart Grid Framework 4.0, and it's going to be out in the next few months. And a significant portion of this document is given over to understanding the communications and control protocols that accompany the electrical system that is there to serve. And in fact, one of the members of the panel, who's from a large transmission and distribution company, said that we monitor the health of our command and control system, I would call it from my Navy days, at least as intensely as we monitor our electrical system. It's that valuable, and it's going to get more valuable. And we heard with that connectivity comes the risk of cyber. Now, certainly as we add more and more renewables and similar aperiodic sources of generation, many at or near the edges of the T&D systems, that comms network is going to be essential. And now it comes with it is a demand to ensure that the products that manufacturers like NEMA companies make are not only ready to operate electrically, they have to be cyber secure in your networks when they get there. And that's something most manufacturers haven't had to confront as intensely as they have now, and will have to more in the future. I would say, just in deference to the transmission aspect of this conference, the utter essentiality of that movement of power over distance, especially when you look at the machine that was shown in Rob's presentation this morning, that is North America. And you look at the size and the scale of that, and understand the transmission pathways, or in China, the size and scale of a transmission system in that country, in that region. How important that transmission is as a vital arterial system upon which the rest of it's going to be based. There will be microgrids, there will be islanding off, there'll be all the things we're hearing about, but at the end of the day, at scale, at distance, is going to be an important part of any grid in the future, I would think. Just one plug on behalf of manufacturers. I'm pretty confident that you all know how to plan and run your systems, and I'm pretty confident that the manufacturers know how to plan and manufacture what you need to make that system work, be it the extant system that's in service today, or new systems with new capabilities, many of them electronic, all of them connected to the grid that we're going to need in the future. And I would hazard to say also that especially our larger companies will be developing the digital skills and depth necessary to help you with the data that these devices and others on your systems will be throwing off, so that we can incrementally improve not only our product performance, but at the end of the day, your system's performance. So as you experiment and adopt new approaches in this dynamic world, we heard about in the transportation just being one aspect of it, your manufacturer partners are going to be sprinting to keep up and to make sure that you have what you need to make your systems work. So Ted, thank you.
Great. Thanks very much, Kevin. And Manlio, would you like to go next, please?
Yes, thank you. So let me tell you, first of all, that I'm embarrassed to take the floor after Vice Admiral and Commander Cosgriff. This is because I'm a simple former retired sergeant of artillery of the poor army of Italy. So I'm totally embarrassed, Vice Admiral. I'll do my best.
I got to stop you, though. Tom Kuhn, who I mentioned, was a lieutenant in the United States Navy about the same time I was. Okay. And I always tell him we peaked at the same time, so don't worry about it.
Okay, thank you very much for the floor. Once again, Manlio Coviello, president of Terna Plus, which is a part of Terna Group. Let me give you some idea of what Terna is. Many of you, I think, do not know. Terna is the largest TSO in Europe. It's the owner of a national Italian high-voltage transmission grid, manages planning, development, maintenance, bringing together skills and technology, and most lately, innovation, and we will talk about innovation later, of course. Is listed on the stock exchange since 2004, is among the biggest Italian companies, has around 73,000 kilometers with 872 stations, substations, 25 interconnection with foreign countries, and 4,000 people employed. Most importantly, in 2018, has been recognized as the first in the world of the electric utility sector of the Dow Jones Sustainability Index. Sustainability for us is fundamental. And finally, Terna was a member of Edison Electric Institute, and we will really hope we will be back. Lawrence. This occasion is particularly important for us, and I'm very happy to be here, first time in Vancouver. Since Terna is one of the leading TSO in the world, and with a presence abroad, mainly in Latin America. As a matter of fact, I'm based in Santiago de Chile because of this focus we are giving to South America by now, and other Americas maybe in the future. Increasing global electrification of renewables generation capacity have to be integrated and will entail higher needs for grid investment. The International Energy Agency says that in the next 2 decades, approximately $20 trillion will be invested in power sector globally, and for every euro or US dollar spent in new renewable capacity will entail €1 or dollar in grid infrastructure and grid-related services. And this is very important, at least in my view, since I've been hearing a lot of pressure on renewables. The renewable will solve the world. Only renewable will do it, and definitely this is not the case. You need a structure to make renewable work. The overall scenario is putting under pressure the main pillars of the TSO mission. Of course, the global decarbonization targets are also part of this pressure. And in particular, these pillars are security, which is the capability of the system to deal with unforeseeable events; resiliency, the ability of the system to withstand grid stresses; efficiency, that guarantees security, adequacy, and quality of service at the minimum cost for final users; adequacy, to meet the expected demand in any condition; sustainability, and finally quality, that means ensuring continuity of the service. People, regulation, innovation, and digitization become key to put in place a set of managerial sectors. To better manage energy transition, it will be necessary to implement a complex mix of measures in several technological and operational areas, in particular capacity market, network development, storage, demand response, smart grids, market evolution, and data management. And I'm sure we will go into detail later. Thank you very much.
Thank you, Manlio. And Tom?
Great. Thank you very much. It's a real pleasure to be here. Thank you again to EEI, Daniel Knoll in particular, and Lawrence for getting EPRI here. I guess I feel really unworthy, given that I was not in the military, but I was an Eagle Scout, if that counts. I used to lead trips with the Sierra Club, so there we go. What I'd like to talk about, I'm not as my intro said earlier from Ted, I'm not a T&D person. So I'll talk about a couple of things I do, which is planning, in particular electricity planning for many, many years, and more recently energy planning, because it's hard to draw the boundaries now between electricity and energy. 3 points I'd like to touch on in my opening remarks. One is load and load growth. Francis Bradley brought this up yesterday, referred to a report that we did last year on looking at the future, and so getting into that a bit. The second point will be with regard to planning and the challenges we have in planning and a report we did there. And the third, we'll talk a little bit about a new initiative on artificial intelligence and trying to deal with a massive amount of data that's appearing both at generating facilities, at T&D points, and also at end use. So in terms of load, we had this report that came out called the U.S. National Electrification Assessment. If you Google or DuckDuckGo, if you don't like Google, if you DuckDuckGo efficient electrification, you'll find all the reports. You'll find a newsletter that'll be interesting to sign up for, hopefully, and various things we continue to do, including conferences. The real intent of that work was to try to understand where load might go in the future. Our starting point was the Energy Information Administration's projection that the GDP would grow about basically double by 2050 from today. Their projection that service demand for energy, the amount of lumens you want, the amount of vehicle miles traveled, the amount of heating and cooling you'd want, would go up by about 60%. So not as fast as GDP because of structural change in the economy. We produce $1 of GDP now with Microsoft, Apple, and so on, much more energy efficiently than our previous economy worked. And so those service demands go up. Given those projections, we estimated in our study that the traditional loads for electricity would go down. They go down about 10%. If you start to look at self-generation, distributed generation, that grid-supplied electricity goes down by even much more. Then you add in the potential for electrification. Transport electrification happens in all our scenarios. Francis mentioned that our range was 24% growth by 2050, up to 52% growth. The 24% assumes fairly slow, relatively slow introduction of electric vehicles. The sort of 32% range is faster introduction of electric vehicles, but no carbon policy. If you have carbon policy, you start to see electrification in buildings, and you start to see it in industry. Without that, we assumed $3 gas forever, $3 per million BTU gas forever in the U.S. That could not happen if we have certain people elected president in a year, but that could be different. But assuming that gas price, it's really hard to compete in homes and in industry with that cheap gas. So very different pictures, the range driven primarily by having a carbon price in that 52% scenario, by not having a carbon price in the sort of 30% growth scenario. I want to emphasize, though, 50% growth sounds huge. It represents a lot of transmission and distribution, but it's about 1.2% a year. So this is not exactly the wild, wild west in crazy times. It sounded very good, I think, to the gentleman from Manitoba Hydro yesterday. It would not sound good in China. It's the rate of growth. So for load, we see it going up. This is really important because if you want to make the investments in modernizing the grid, having load growth is essential to keeping cost under control. So let me move to the problems that we see as we start to integrate more renewables, as we have this new load coming on, as we have increased demands from consumers for resilience, reliability. Reliability when I was growing up was, if the power went out, you wondered what was in the refrigerator, right? It was about all you really worried about when the power went out. Now, of course, it's very different. We put out a report last year. It's called Integrated Energy Network Planning. If you look for, actually you can go to www.integratedenergynetwork.com and you'll find our work in that area. It listed, after 2 years of deliberations with people from 4 continents and ISOs, utilities, and so on, it listed 10 different planning challenges going forward. We started with about 120 and sort of whittled it down and aggregated till we got 10. I'll touch on one in particular. In the US and in Europe and elsewhere, we have been trying to separate generation, transmission, distribution, and we never had customer models before. We tried to separate them over the last 20 years as we deregulated. It's essential as we move forward to integrate them again. And that's actually being recognized. In the US, the National Association of State Energy Officers, the National Regulatory Utility Commission are both having a 2-year process to try to figure out how to get at GT&D planning, or generation, transmission, distribution, and increasingly customer planning, all integrated again. This is essential because now you have resources at the distribution level that can provide system services. And so integrated view is essential, just from the electric sector alone. We went through another 9 different types of activities that need to be done. EPRI is working hard on these. I didn't mention at the beginning, but EPRI has about $100 million a year aimed at transmission, distribution, and end-use research. And so it's a large activity for us, a very central activity for us. I guess the last thing I'd like to point out is we have another initiative trying to deal with the massive amounts of data that we're not making very good use of today, and that's aimed at artificial intelligence. It can be applied in a lot of areas. One of the initial applications we're looking at is just trying to look at those thousands and thousands of pictures of transmission lines and poles, the thousands and thousands of hours of video we can now get by flying drones over those and collecting data and trying to recognize problems that haven't happened yet, problems that have happened and just trying to pinpoint them. So doing that with AI is very promising. Based on a 1,000 picture training set, there are 3 or 4 faults that you find in poles and transmission that you can actually start to identify with 90% accuracy just with 1,000 pictures. So it's pretty impressive what people are able to do. So EPRI's perspective on this and how we fit into this AI field is we want to be a data aggregator, a data curator, a data protector, a privacy protector, and so on, to get data and be the middleman between the utilities who have the data and the AI firms out there who are trying to have advanced approaches everywhere. Just provide a playing field for those folks to start analyzing the data. So if you're interested in this area at all, we put out a white paper last month. It was the first white paper from the effort. The website for that one is ai.epri.com, or just search for ai.epri, and you'll find that material as well. There'll be a series of white papers. There'll be a lot of communication. But again, trying to play that sort of middle role between raw data and the AI firms that are making advances every day out there. So thank you very much. Appreciate the opportunity.
Great. Well, thank you very much. With those opening remarks, again, if you have questions, feel free to submit them or shout them out. But I'll start with one here. Hailing from California, I have to admit that I had a fairly steady parade of Silicon Valley startup company executives coming into my office one time, and they all had an intriguing new technology or innovation, and mostly they were looking, of course, for some sponsorship in buying that and getting it incorporated into the system. And what I found myself often doing was asking, well, help me understand, what problem are you actually solving here with this technology? What's the actual reason we need this new technology? And that's usually where the conversation kind of broke down. They didn't really have a good understanding of the business, and so they saw this as a really good technology, but not really sure what problem they were solving. So the question I'd like to pose really across the board to the panelists here is, how do we determine the value add of a particular innovation or technology? Maybe said differently, how do we determine that this thing is good, or even if it's of sufficient value to warrant expenditure or development? So perhaps I'll start with you, Tom, on this one, but how do we evaluate whether particular technologies or innovations are actually worth investing and spending time on?
Yeah, so that's a great question. You know, I'm a modeler, so the answer is going to be models, right? But, you know, frankly, it's very humbling where we are right now with the modeling. We have a hard time telling you the value of having a battery in a specific location. We know what a battery is, and we know how it operates, we know the cost of it, you know, we're actually installing them, and we have a hard time telling you if that works and how much how much value it has. Mm-hmm. So looking more broadly just requires much more detailed and integrated modeling. When I talked about integrating generation, transmission, distribution, we really can't tell how much some of these distribution technologies that are walking in the door literally every day, or how many advanced batteries are walking in the door every day, or new programs for aggregating consumers using smartphones and other digital technologies. I mean, how much they're worth without taking an integrated view of the system. And we're not quite there yet, but that's where we basically need to be to value that, I believe.
Kevin?
Yeah, it sounds sort of like a pain point question. You know, where are the T and D companies struggling, and you know, we heard about the duck curve and the different phenomenologies of aperiodic generation from multiple sources or distributed energy, call it what you will. And we had one of those companies approach us, and of course we're always interested in new companies. We're a member-based group, and it's basically a distribution edge device, which is a volt-var service provider. And the theory, the macro theory around that is, well, if we can get this right all the way down there, we should be able to generate less all the way back in the generation house or phase for the rolling for the fossil fuel based generation. Well, that's pretty, you know, a small change there is quads of power saved and everything that goes with it. So I think this is a case where the operators are going to have to tell us what they're struggling, and us being researchers as well as manufacturers, where the struggle really is today and where they see it in the sort of business relevant amount of time, the next 8, 12, 18, 24 months, and turn manufacturing loose on it also.
Yes. Well, Terna has a very pragmatic approach to innovation, and I like it very much because I'm a physicist and I like numbers. You can tell me a lot of things, but we discussed it yesterday. Numbers are too much important for many of us. For example, batteries, which is something an issue that is going around. We decided at Terna to create a test and validating pilot project in Sardinia, which is an island in front of Italy, for electrochemical storage. So we installed 5 types of lithium storage, battery storage of 9.2 megawatt, 2 types of sodium nickel chloride 3.4 megawatt, 2 types of vanadium redox flow at 1 megawatt approximately. We are testing there, and then we take it to our storage system in Campania, which is close to Naples, in order to handle the interruption and the variability of wind in that area. Only at the end of this process, we will see numbers in terms of technical performance and economical performance. I would say that should be, in principle, a way of coping with this issue. What's the added value and what's the evaluation of new technologies? Test it and prove it.
So, got to remember to keep this thing on. Saw a question in the back.
Great, thanks. Yeah, Justin Cruson here, Canadian Electricity Association. So maybe a little bit more of a distribution question, but as you say, it's all kind of one now. But it concerns advanced metering infrastructure. I've spent a lot of time the past year or so working on modernizing regulations with our regulatory body in Canada, Measurement Canada. But over that time, I've been convinced that really AMI is underutilized infrastructure, essentially. I was just going to ask the panelists, do you agree with me on that? And could you maybe expand a little bit on, you know, what a more fulsome utilization of AMI could look like?
Go ahead. Go ahead.
Yeah, so, you know, I'm a case example of how it's underutilized. I've been getting a check from my local utility for not using an air conditioner that I don't have for a number of years now, despite my advanced meter sitting there. But, you know, I'm happily collecting my $50 for not utilizing it. Yeah, there's a lot we can do. It's interesting to, you know, some folks wonder about how AMI is getting leapfrogged by all the other devices that are having controls and information flows in your house. You know, how do you tie together a Nest thermostat and your AMI and various other data streams? Will that ever be possible to try to get a better feel for what's going on at very low cost, because these things are sort of integrated. They're happening all the time. So I think it's sort of broader than AMI and how to utilize that data per se. Soon we'll be getting into trying to control through the meter, getting more control through circuit boards, getting control. We have a circuit breaker, I guess, that we've been working on and testing for a while now that will allow you to control those circuits just by sticking a breaker in the panel. As it currently exists, it will work with electric vehicles and so on. And so those types of technologies are just at the cusp that may sort of coordinate with or leapfrog some of the AMI capabilities.
Yeah, one of the realities of having equipment provided to someone else to operate is especially equipment that can join up meters by definition or intended to connect and into some cases eventually control, is who gets the data. There's data ownerships, there's data privacy issues when you're beyond the meter, but who gets to use it? And in my simple steam engineer sort of mind, it's like a pipe, and when it fills up and you don't want to have too much pressure, you just dump it overboard, right? So there's just teraflops of data going out onto the ground all over the place because nobody's recognized the opportunity, the business opportunity of understanding that. Manufacturers might want it for product improvement or maybe process improvement, as the case may be. Operators, I would think, would want it to tweak their system and get it to run better. But anything like that's going to be a business cost. You're going to have an investment to get the data analytics in place. Chances are your company doesn't have, a department of data analytics already. I know even in our big companies, they're just beginning to get to that point. If you outsource some of your things, as we heard earlier today, maybe some cloud-based, then yeah, the Amazons and Microsofts, it would be a relatively new sector for them, but I think that's the sort of way we ought to be thinking is how do we tie into the people that actually are on the front edge of machine learning and eventually AI and bring them into our world rather than wait for them to disrupt it.
Very briefly, more or less at the same line, remember that Terna is a high voltage transmission company, so we are not exactly in the smart meter or smart grids. But here there is a point also, coming back to technology. Technology is not enough. Digitization, fantastic, you can do whatever you want, but then at the end you need a regulation for that data exchange between DSO and TSO. And in many countries we are looking at this real problem. I mean, who's the owner of the data? Which data can be shown, can be exchanged? So it's not only technological, but regulation in this area is fundamental. And let me add something about smart meters. I don't know if you are aware. The government tried in Chile to sell to the society the idea of smart meter, and society said, no, I don't want it. Simply like that. So it's not enough technology. There's something more that if you really want to make some advance, there is something more in the electricity field, which is the way you present things, the way you show the benefits of things to the society.
Let me just add one thing. The advantage of having a medical imaging organization inside an electrical one is you get exposed to things that ordinarily you wouldn't. Privacy of medical information, in this case, a medical image, is a form of ownership, right? I mean, so somebody exerts some level of control over that image. But as fellow travelers in this experience called life, we all know we're going to have an intervention at some point with medical. And chances are, one of the premier discoveries of the last millennium, medical imaging, will be part of your diagnostic process, and it could be part of your therapeutic guidance subsequent to the image. And we know that for a white male of my age, in my demographic, there are literally hundreds of millions of medical images on file that are accessible today. And we know that there's machines that can crunch through that and very quickly make logical inferences. And we know that there's medical imaging done by machine is, I apologize to any radiologists in the room, is as good in gross differentiation as any good radiologist is. And so with all this information available, we should put it to work. Now, when you talk medical imaging, it's very personal, it's very human. You can get your head around it as an emotional thing. You maybe don't think about the grid that way. Maybe you think about the grid in emotional terms, but I only think about it emotionally when it's not there for my whatever, my watching
Football game.
television. I don't watch football. My wife would go nuts on a football game, but yeah, American football. I'm more football. But but these are the sorts of problems I think we ought to, especially big organizations representing big operators, ought to think about it. Is there information we could share? Think about the value add, not just the ownership.
Justin, I'm just going to ping one thing that I think it really hits home on a lot of innovation and technology, and that's the obsolescence cycle. One of the experiences we had in California, which was an early adopter on advanced meters, PG&E was the first adopter, and they ended up putting in several million meters, but the technology had not advanced far enough at that point for those to be two-way communicating. So if you needed to make any improvements in the software, you really couldn't do it. You couldn't, in a sense, upload improvements. So they ended up having to scrap them and put in new meters, and didn't even get a full return of capital from the regulators as a result of having to scrap that. We had a similar issue. We had two-way communication by the time we put them in, but we found we weren't really getting visibility to outages from the advanced meters. So part of what the company was doing just before I retired, and it continued on doing it, is trying to make software upgrades that would allow the meters to really operate effectively as identifying where outages on which feeder lines and where on the feeder line those outages were. So this leapfrogging of technological capabilities and just the speed with which those things happen when you have these multi-billion-dollar investments, I think is one of the challenges that this industry will continue to grapple with. And the fact that depending on the jurisdiction and how they view technological advancement that can result in a loss to the company, either in terms of return or even a loss of capital invested. There was a question here. Yes, please.
Thank you, Mr. Craver, bringing up the startups. As one, Universe Energy, we're probably the only one startup company in the League of Giants here. So from a future grid planning perspective, we developed an innovative energy policy tool, which is called Regional Energy Hub Framework, enables Paris Agreement countries to assess and originate interconnector needs among them. Regional Energy Hub Framework consists of 4 major parameters: geopolitical, economic, environmental, and financial parameters. Our unique solution and contribution as a startup is, and you can value that hopefully after the network, is the use of geopolitical parameter for the Paris Agreement countries to form regional energy hubs based on the following criteria: international economics, seamless energy markets, transnational politics of energy, and energy market regulations. We want countries to meet their Paris Agreement targets through investing in a common interest assets such as interconnectors, so that they can regionally optimize their fuel mixes, enhance trading, and reduce emissions. As history shown, trade, not isolation, has enabled humanity to progress further. So if you want further information about that our white paper, it's oneuniverse.energy. Look forward to your further discussion and collaboration. Maybe you can value my business after that discussion. Thank you.
Thank you. I'll take that as a comment. And if any of the panelists want to respond to the comment, otherwise. Okay. Thank you. Yes, Lawrence.
One question. So we've heard about Tom talking about artificial intelligence. Manlio talked about data, and Kevin talked about also about technology imaging. So I just want to have a question about technology-human interface. You still need humans to build these transmission lines. So can you comment on this interface? How do we make it work going forward, especially from a transmission side, where you saw those people climbing those high poles to put up the steel towers? How do we deal with things like virtual reality, augmented reality? Can you talk about how we make the interface work? Because oftentimes technology is the main thing, and we forget that you still need humans to put the lights on. So I'd love to hear your thoughts about the interface technology-human.
Yeah, it's not my particular area of expertise at EPRI, but we do have a sort of worker safety, worker augmented reality program at EPRI, where we actually go out and give different instruments, different types of glasses, different types of headsets, discuss whether it's safer and more valuable to hear information as opposed to read it on a little screen. And so we're actually doing field testing in T&D of these types of technologies to see what works, what doesn't work, what problems people have with it. Some of the original equipment was so bulky and hot that if you worked in Alabama, then you'd be sweating profusely. It just didn't fit, didn't work. But it might work in northern climes. And so, yeah, we're just going out and field testing a lot of different things.
I think if there's one thing that keeps the member company executives maybe not awake, but tossing and turning, is workforce development. And I'll speak to the United States, is having job-ready 18, 19, 20-year-olds is a challenge, regardless of what sector. And I meet with my contemporaries and other associations, and virtually all of them, like NEMA, have a workforce development initiative underway. Ours includes most everything in the electrical world. It doesn't explicitly go to the example you gave, although climbing high object steel towers is something I don't really mind doing, especially if they're moving, but that's me. But in the electrical world, using augmented reality as a way of extending the knowledge level of the worker, who's hard to find to begin with, I think is the way we're going to do it, both in the production side of things, where we're seeing the increasing use of robots as co-workers with humans without having the robot in a cage. And we similarly, in the installed, pick a building in this room, for instance, when somebody's installing things, having that installation aid readily available, maybe via an augmented reality tool. And similarly, the inspector that's going to come behind the installer and inspect it can't possibly have mastered the 2,000 plus pages of the National Electrical Code, but augmented reality can make him a walking, talking expert just by looking at the scene and having the answer populate to his eyes. So there's great opportunities in bringing that technology to bear in the near term.
Okay, thank you. Well, in addition to having been a sergeant of the army, I have been for a long time UN officer. So let me speak as UN officer in this case, which is something that I was always saying at that time, which is this phrase, which is sustainable development is feasible only if you add society and territories to the equation. It's not enough environment, the three pillars of sustainable development, all the technology you want, all the policy regulation you want. If you do not have society and territory, you don't go anywhere. And we saw it yesterday, this incredible, fantastic project of Ontario, right? It was Ontario. That they really did it. They really made a sustainable development with territory and with society. I really have to congratulate with them. But what is Terna doing in this case? For example, we will, in Italy, for example, society said, I don't want to see any more cable on the air. So 60% of new extension of the grid will be underground, no matter what. This is, and we had to do it. We had to see high voltage, and of course with data in it. And then, for example, in the new National Development Plan of Terna, there are new competency-based assessment indicator which assign value to the benefits in terms of society, territory, sustainability, not only on economics and return. So this is the way somehow we think it should be done. So it's a very opportune question.
I can't help but add a little piece on there. We had a major transmission line, the Tehachapi line, primarily to bring renewables out of the Tehachapi Mountains into the load center, 500 kV line. So for us, it was one of the higher voltage ones. One of the communities, even after the transmission line had been approved, one of the communities continued to lobby and pressure for the line to either be rerouted or brought underground. Ultimately, the commission decided that they would revisit their decision and ordered us to underground it. And the cost of that, which of course was borne by all ratepayers, not just the community involved, this was a 4-mile stretch that had to go underground at the cost of $100 million a mile. So $400 million additional cost. So when you bring the community in and the other parts, there's a cost element in there too, and the fairness of how that gets spread across everyone else. So these are interesting subjects. In fact, the whole issue of undergrounding high voltage lines, I think, would probably be a panel in and of itself. I want to explore just one piece. We're beginning to run a little short on time. And that's supply chain. If I remember the slide correctly, actually the top risk that Jim Robb had mentioned in his presentation on NERC was supply chain. And certainly the work that Jim and I have been involved in over the years with cyber has also focused much on the supply chain. So with all of the potential disruptions to supply chain, be it from cyber or be it from trade disruptions, I'd like to ask the panel, what should the electric utilities and manufacturers do to try to reduce the risk inherent in supply chain, particularly as our supply chains have become much more complicated and widespread?
Well, I'll start with us. When the West Coast United States had a longshoreman strike, it was about 4 years ago now, that was a major wake-up call to electrical manufacturers who source a lot of their components from Asia, principally China. And so trying to run a just-in-time manufacturing process with all the process improvements that have been put in place over the last decades without that supply chain, which was assumed to be there, was a hurdle because there's a finite number of ships, there's a finite number of berths in the various loading ports, there's a finite number of, you're not going to move a Maersk liner in the North Pacific to a port in Mexico because it's convenient for you to get one container off it. It's a joined up, highly efficient global infrastructure transportation system, as this example would tell. So that's one type of supply chain. I think there's an information supply chain or a knowledge supply chain. It touches a little bit on what's going on with the workforce development. There's lots of good business schools around, but I think I would worry about schools in the higher education I'm talking now that are going to provide the knowledge, skills, and ability that companies are going to need in this century. We're a fifth of the way through the 21st century. I should probably stop talking about it like it's new, but what's the next 20 years going to look like? And where are those skills being taught, and are they being taught both at the scientific level as befits a physicist, but also in the business and practical levels, especially in the areas of information technology and networking?
Very briefly, the risk of disruption of the supply chain is very present, and this is why, for example, Terna is working with two research centers in Italy. One is CESI. I think many of you know CESI or CESI. I don't know how to pronounce it in English, and RSE. Exactly on this the way of how to use technology to reduce the risk of disruption, and but in general we think this is part of what we call at Terna the TSO 2.0 model, a new way of understanding and using technology that are not only efficient, not only intelligent, but secure. So we are investing money exactly in this area, and we will soon see some results on that.
And from EPRI's perspective, I wrote a paper in 2017 called the Integrated Energy Network. Again, you can Google that and it'll pop up. Basically recognizing that the energy system is interconnected in many different ways, but it's not integrated. There's very little visibility into gas supply for many power plants. There's very little visibility that there's going to be an electric outage that makes the gas pumps go down in the pipelines. All of these things are tied together. If one fails, they all might go down. And whose supply and whose demand is it's a circular kind of issue at that point. This came up in our electrification study as well. We saw for a lot of northern climates with today's heat pump technologies that it made a lot of sense to have both dual fuel gas and electric heat pumps. Because first of all, it was mentioned earlier for Europe, if you have a heat pump in a climate where you already have a winter peak, adding electric heat makes that winter peak even higher, and so you question how much you really want to build out a seasonal grid. But if you're in an area that just has both gas and electric available, having a heat pump that primarily uses electricity when weather is at reasonable levels, when it's not too cold, that also has the capability of running off of gas and providing you heat when you have a shortage of electricity or vice versa, provides resiliency. Now, of course, you have to have heat pumps that don't not operate when the electricity is off. are able to use the gas. You have to have heat pumps that are, if the gas is not there, able to run on electricity only. But, there are a few things that have to happen to the equipment, but those things are within reach in terms of providing resiliency and supply and enabling the system to adapt if you can control and integrate.
Well, we're really out of time, or a little bit past our time. Just going to finish with one last teaser question. Tough one to answer. Get your crystal balls ready. So if, at least in my mind, when I think of technology and innovations, I think in terms of the disruption or the potential disruption that those can cause to incumbents. And that's certainly been a hot topic for several years now in this industry. If I think about it, I would say probably the best example of a disruptive technology in the energy sector was actually fracking. It's completely reordered many industries and reordered really who the players are. Time for the crystal ball. If we think in terms of the grid, think in terms of transmission and distribution, is there a disruptive technology that you see coming down the line that could have a similar impact on the use of electricity, on how we deliver electricity, similar to the way fracking reordered the oil and gas industry? Or do you see it as really more of just a constant stream of smaller evolutions, nothing that would be as disruptive as, say, fracking? Manlio, I'll let you go with that one first.
Well, so I'll be trying to close in a funny way. In transportation, the real breakthrough would be what I call the quadriceps technology. That's the real change. Quadriceps. That's the real way in which you can do things in an efficient way, no congestion, no pollution, no climate change, if ever, and all the rest. And electricity, of course, that would be nuclear fusion. I mean, thinking that from exactly this quantity, you can have all the energy you want for a couple of days in Vancouver, that would be the real breakthrough in terms of energy. But it's just. Do you see that coming? No, I don't see it coming. I don't see it coming. I've been working with the Nobel Prize on Physics, as you know, so there's been a lot of discussion on that. A few years ago, he said 2027, 2026, maybe we could have it. And now he's not so confident about these things. But if you ask me, these two things will be the real disruption: transportation by quadriceps and water producing energy. That would be the real one.
Before I was disrupting the government of Great Britain by my visit, I was in Denmark, and you just get used to very quickly the quadriceps on bicycles all over Copenhagen and elsewhere. But anyway, I would tend to think that along with fusion or something like that, hydrogen would be another example of that on the fuel side, would be the atomization of the grid, meaning that more and more of us are able to live off-grid longer and longer. I think that would have real business implications, not to mention other beneficial implications for it.
Yeah, I guess I'll try to name two as well. My big one for right now is seasonal storage. That's cheap. I think we can deal with diurnal storage, but seasonal is really hard. Moving the sun from a August afternoon to a January morning for a heat pump is a challenge. The other is it's actually not in the technology side, because I think we'll have the technology to understand what people are doing and to control appliances and do whatever. It's on the societal side. It's on the policy side. It's on the behavioral side of actually being able to do that, because you could get, in the U.S., people estimate maybe 20 or 30% of our load controlled real time if you were able to get through that soft part of the problem. And so that would be a different kind of breakthrough.
Well, thank you very much to the panelists and for the questions. I think we'll wrap it up at this point, Lawrence. Thank you.
Thank you for an excellent panel. And so just stay in your seats. We're almost there. I know it's been a long